Hello, in this video we're going to be looking at displaying nearby players with a custom server. So what we are doing is basically in the previous episode we've started synchronizing our character. So we've been sending updates to the server about the location, rotation and velocity. And now what we're going to be doing is basically fetching information about nearby characters as well and rendering them on the screen. So these are the points that we're mainly looking to cover today. So we're going to also update the motion only when the motion's changed. So this is part of the performance improvement. Creating a proxy character blueprint. So this is basically taking the player character blueprint that we had before and using that as a parent to the new blueprint, right? So this way we're going to be reusing a lot of the code rather than sort of duplicating it. Decoding nearby player's message from WebSocket response. So basically we're sending a message with a motion, and now we're going to be also getting back a message with other players' response. So we need to process that. So convert the JSON to a structure and then process that information. So we have to evaluate whether the data of the player is a new player, existing player, or a player that we need to delete from the screen. And then we also want to process the motion of that proxy character. So that's what we're going to be looking at doing. One thing to mention is that there's a bug in Unreal 5.0. So this is when you open up two clients and you try and change in a map, it's just going to crash. And it was really frustrating, to be honest. This was the bug. In order to work around it, I had to custom compile my widgets that I'm using. So there was VA REST and the Easy Blueprint, Easy WebSocket or Blueprint WebSockets into 5.1. This was a bit of hassle. I included some of the steps down at the bottom on how to do it. But to be honest, I would really advise people to wait for 5.1 to be out, which I think it was literally out yesterday, and the plugins to be updated to 5.1. So update your project and then things will work as expected. So yeah, let's begin with the demo. So in the demo, what we're going to be looking at is, well, let's start. And now we have two clients. So in fact, what I'll do is I'll show you the settings. So you can see number of players 2. So we're going to be opening up two clients, net mode, play standalone, so we know we're not using Unreal Engine replication. All of the networking is done, well, in the client, right? So these are the things that we'll be looking at. So you can see we open up two clients, and yeah, it's starting to look more like a multiplayer game, right? So log in as character 1 and log in as character 2. So FYI, this is where the crash would have happened with 5.0. So this is where you'd need the 5.1. Okay, cool. So basically, look at this. So we've got two characters now. So you see, like, we're able to move around, walk around, and the characters basically synchronize across the two servers. So the other thing to mention is, like, if you go far away, the character disappears from the screen, right? So we've got a distance threshold, and if it goes past it, the character will be deleted. One of the performance optimizations that I've made, as you can see, like the character disappeared off the screen, is I'm only going to be updating the motion if it's changed. By default in the server, I check whether the motion was updated over the last, I think, 1 minute or something, I'm not sure. And if it hasn't been updated, it considers that player to be disconnected. So one of the things I'll need to do in the nearby enhancement is basically send a force update every 10 seconds, 20 seconds, whatever time period, just to basically let the server know that this person simply not moving is not disconnected, right? So it's just a little enhancement that I'll make in the near future. But that's it for the demo. So that's what we're going to be looking at, synchronizing the motion. Just bear in mind that the appearance information is not synchronized. This is something that I'll do perhaps in the next episode. We're specifically looking to spawn the proxy character and synchronize the motion of that character. So next we'll look at the implementation. So we'll begin first with optimizing our update. So basically inside our player character, we're going to be sending updates to the server, and we only want to update the database when the motion is changed. So this is handled inside the player character blueprint. So part of the synchronized motion flow. At the end, we've got this update timer. So this implies that every 100 milliseconds, we want to send an update to the server. And part of that, we're going to be updating the player motion structure. So we've got a player motion structure over here, and we want to update it with the current data of this character blueprint, right? So inside here is where we make some changes. So specifically, we want to first record what the previous motion was. So that's how we'll evaluate whether the motion has changed, right? So first put the current motion in the previous one, and then evaluate the motion as you did before. So basically taking the self, getting the location, rotation, and velocity, and filling out all of the details on the player motion. And next, you just want to check whether the two motions, the previous one and the current one, are equal. So Unreal Engine did not have a native recursive function for evaluating whether the object is equal. So I had to create a little helper function to do that. Basically, you have a function, take in two of the motions, break them out, and go field by field, comparing if they're equal. So it's a bit of a hassle, but I didn't see Unreal having a recursive method of doing this. If you do know of one, do suggest it on the comments, because that would be pretty useful, certainly in the future as well. So it'd be nice to have. But ultimately, it's not too hard to make one of these as well. So we compared whether the motion is equal, and we only want to update if it's not equal, right? So that's what we've got over here. So for reference, this is what we want to construct. So when we've got our WebSocket connected, these are the updates that we're basically sending. We're sending, this is the motion, and update true. That implies that the motion's changed, just update the database. That's what it's telling the server to do. Okay. So yeah, let's go back to synchronize motion. So we've now updated the player motion. What we want to do is now construct the JSON object. So like I say, this is the message that we want to send. So this is the message that we want to construct in JSON. We already created the JSON structure for this one. So now, and I think it's actually over, let's have a look. So, motion to JSON, right? So this is the one that we've basically looked at in the previous episode, and now we just basically wrap it in another object, which basically says update to the update field, right? So you basically just reuse a lot of the functionality from the previous episode, and you just simply wrap that object in another JSON object, right? So again, this is one of your motion objects, and now we wrap it inside this one, where we also specify update. Okay, and that's basically it for the performance optimization of basically sending the updates only when they changed. Because basically after that you send the message, and this is the same as before. So the next thing that we'll look at is basically how we created the proxy character and what does it consist of. So the proxy character, I'll first show it over here. So what it is basically you create a new blueprint and you define what's your parent class, right? So the player character, so we know we have a player character, so this was the player character that we've basically been working on, right? So make that the parent of the new proxy blueprint. So that will create this over here. You can confirm whether it worked correctly by looking at the parent class at the top right of your blueprint. So that's how we basically inherit all of the blueprints from your main class, which is exactly what we want, right? We don't want to be duplicating that code, because we know that one of the things that we want to be reusing is the appearance information, right? So we want to be utilizing that as much as we can. So let's have a look. The first most interesting part is inside the constructor. So what we did was inside the player character blueprint, we've added a new variable called isProxy. So not everything that we use in the player character blueprint wants to happen when you're a proxy. So one of the clear obvious ones is we don't want to be sending motion information to the server if you are the proxy. Right? You just want to mimic other players. You don't want to be sending any updates. So this is predefined inside the constructor. So part of the constructor, we're basically saying prepare the dynamic material instance. This is a requirement for you modifying the appearance information of this blueprint. But after that, we check, is this blueprint used as a proxy? And if not, you want to set the position, set the appearance information through the game instance. So this is what happens when you log into the game through the selected character screen. And you're also creating a WebSocket. So again, these things you don't do if you're a proxy, so you can see it false here. So by default, isProxy is false. and we're going to be setting it as true inside the player proxy character, right? So you can see that over here. The next thing that we'll have a look at is the player character blueprint, and we want to have a look at decoding the nearby player's message from the WebSocket. So part of the flow where, for example, we bind on send, bind on connect, etc. We also want to bind on message received. So what this implies is that every time we send a message to the server, we expect to get a response back. And the response will contain information like, well, basically the nearby player's motion, right? So we want to decode that message and convert it into a structure. So that's what we're going to be looking at here. Before we get onto that, I want to say that we also want to initialize the VA-REST JSON object so that it's not null, basically. So we create a parameter called nearby player's motion. I think it's over here. And yeah, just make a JSON on it so that we don't have to make JSON every time we call the event. So this is just to initialize it so that it's not null, basically, right? Okay, and bind on message received. So this is another bind event on the WebSocket client. So bind on message received, right? So every time we receive a message, it will call this custom event. And what we want to do is simply utilize the decode JSON function from the VA-REST library. Again, this is not essential, but I like the VA-REST JSON implementation, so I'm just going to utilize their helper methods over here for that. So if we manage to decode it, so essentially convert this string into this JSON object, we'll go into here. And this is our entry point for the synchronize nearby players function. So if we go inside here, process nearby player motion, so we know that basically when we enter here, we're going to have this nearby players data set, or rather this nearby players motion set. So inside these synchronized nearby players graph, we're going to be synchronizing the proxy surrounding our player. So synchronized motion was synchronizing our player's motion, and this one is synchronizing the proxies around us, right? So in order to do that, we want to be processing the nearby player motion JSON. So we're going to be getting the array of all the motions available there. So this array will effectively contain all of the players that are nearby to us. So for each one, we want to convert it to an object and extract the player's motion. So we had a look at this in the past. This is basically just your utility function to get the motion, get the player name, and construct this player motion structure. So once you've got that, you want to start processing the received motion. So once you've finished processing it, you want to delete the remainders, because those are the players which, for example, are no longer nearby, right? So or they've disconnected. So you want to remove them from the screen, and also update the proxy characters. You could do this part of this flow, but it's sort of neater to denormalize that. It will make the blueprints a little bit simpler. So first of all, let's see what is a nearby player's data. So here is a map, and the string here is the key, which is the player's name, and the value is this new structure called character data. So inside the character data, we contain the player motion, account character, which will contain appearance information. We're not actually synchronizing this in this post, but perhaps in the next one. And we'll also have a reference to the proxy character, which is on the screen. So this is going to be populated when we create a new proxy. And when we want to destroy it, we use this reference to destroy that proxy. So yeah, so once we've converted it to the player motion, let's have a look at what happens when we process it. So the first thing we want to do is we want to check, does this is this character new, or is it an existing one that we've processed in the past? So the way to do that is we have the previous data that we just looked at earlier, and we check, does this player name inside the player motion exist inside that map? If it exists, that means it's an existing player. We just simply want to update the player motion on that character. And if it's a new one, we want to create a new one, right? So let's go back to here. So you can see if the motion already exists, if true, process the existing one. If false, process new motion, which will create a new proxy on the screen. So processing existing one is relatively trivial. It looks maybe more complicated than it needs to do, but basically we check the previous data. We find our data based on the player name, which is the key, and here we just want to update the player motion from the new motion that we've received, right? Once we've updated it, we want to put it inside the current nearby players data, and we do want to remove it from the previous one, right? So we could maybe leave it, but we do need to process deleted motion. So anything, any remainder inside the previous data needs to be deleted because it doesn't exist in the new one, right? So for instance, they went out of range or they disconnected. So we need to remove that character from the screen. So that's how we'll be utilizing that one. So that's processing existing motion, and let's see what we do when we process new motion. This one actually requires us to spawn a new actor, and we're going to be creating new character data. So you can see us populating the proxy character with this actor, and the location, so the transform of where we position them, we extract it from the player motion that we've got. So we could be also putting things like rotation and velocity here as well, but actually we're processing it separately over here, so that's why you know, I don't do that here. So for instance, if I didn't need to do this, I actually wouldn't, but it will complain to say you need to set the transform in order to spawn one. Right, so we've now created this character data, and we're going to insert it into the nearby players data map, and again we're done. So let's see what's next. So here we want to now process the deleted one, because we've now processed existing ones and new ones. We now want to process the deleted motion. So as I mentioned earlier, this one actually, again, worth mentioning, only gets executed when we finish processing all of the fields in this array. So then you want to process the deleted ones and update all of the existing proxy characters on the screen. So let's have a look. So here we've got the previous map. Remember, every time we've processed the data and it existed in the previous map, we removed it from the previous map. So this means that any remainders here were not part of the new data we received from the server. So we want to iterate through each one and then simply delete it, right? So you can see here, I get the array element, and the only real one I need to delete is the proxy character. So I destroy that actor. And once I'm done, so once I've finished destroying all of the actors inside, I can go ahead and clear the previous data out. And again, I'm sort of done with that. So let's go back to here. So the last thing that we want to do here, after we've processed the new existing and the deleted motions, we want to update the proxy characters. So here, this is basically updating the values inside the actual proxy character. And I believe that's actually the end here. So like I say, again, let's do a mini demonstration. So we'll log into character one. So here we've got the one character being displayed on the screen. Here we'll log in as the second one. So we can see that we pick up the nearby players information when we leave the screen. So you can see the character disappeared. This is because it no longer exists in our new data. So it existed in the previous one. So that's how we evaluated that it needed to be destroyed. And then once we come back, again, is populated and a new proxy is created on the screen. So yeah, in the next episode, perhaps I'll look to synchronize the appearance information as well. Maybe I'll also make a change where I'll be sending an update to make sure that characters don't disappear, for instance. Lots to cover, but yeah, let's see. Final note is, again, it's probably better to be updating to version 5.1 because there are some bugs in 5.0 which can cause you issues. But hopefully that's helpful. Best of luck and see you next time.